Alright, so this is chapter 7 here. This is linear equations, and all we're doing is just solving for it. Now, I've already pre-written the solutions just because of my voice. I actually got an infection earlier this morning, so I can't really speak properly. It's quite difficult, and it hurts every time I speak, so I'm just trying to keep it as quick as I can, okay? So let's just get to it. So basically, all we're doing is we're trying to find what a solution is. A solution is pretty much a value that makes an equation true. And in an equation, what you're going to do is you're going to find the variable, like what the solution to the variable is to make the equation true. And this is always unknown. It's your job to find it, okay? So if you have a look here, um, this is how you typically start out when you state the solution. So what we mean by inspection is you just look at the question and you can just sort of tell me and gauge what you think the answer is. So a good way to sort of deal with it is like if you look at the first one, 4 plus x equals 25. Another way of phrasing that is saying 4 plus something equals to 25. And what is that something? What does something? So if I add 4 to the something, it's going to get me 25. So what is it? So pretty obvious. You're just going to say, oh yeah, it's x equals 21. Like it makes sense. So just going to do that. And then you're going to do the same for the others. Okay. So I'll just read the other ones. 5y meaning 5 times y. This meaning 5 times y. Okay. 5 times something equals 45. What does that something equal to? That something is 9. Okay. Y equals 9. And for the final one, I got 26 is equal to 3 multiplied by something. And then I add 5 at the end. And then you just figure it out to be the number 7. Okay. So, um, so I'm just going to cover the core parts. I'm not going to cover every single thing, just the main skills you should have, okay? And then like these skills will pretty much carry you throughout the whole thing, okay? So don't do what we just talked about earlier by inspection. I need you to start solving things algebraically, okay? So to do this, all you're going to do is get the variable by itself. And to do that, you are going to apply a series of operations. Now, these are called inverse operations, okay? Now, what we mean by the inverse operation is depending on the operation that you see in your equation, you're going to apply the opposite of it, okay? So as you can see, if I see plus in my equation, um, if we're going to apply plus, then yeah, we're just going to subtract. And then if we see minus, we're going to add. If we see times, we're going to divide. If we see divide, we're going to times instead, okay? All right, so let's just start it off with pretty basic stuff. What I did here was, as you can see in the highlighter, um, I'm trying to get rid of that highlight stuff because what I'm trying to do is I'm trying to solve for the variable. So the letter x in this case. So to get rid of minus 4, I'm going to add 4 to both sides. As you can see, that's what I've done. And I end up with x equals to 20, okay? Now for part B, now you have negative 2u plus 7 equals 17. As you can see highlighted in yellow there, I'm trying to get rid of plus 7. So that's based on the operation that I see. So to get rid of that plus 7, what I'm going to do is minus 7 instead. As you can see, that is what I am doing. So I minus 7 to both sides. Now, what happens is 7 minus 7 equals to 0. And now what's negative 2u plus 0? It's just negative 2u, okay? A lot of people tend to make a lot of mistakes around here, but I'll talk more about these mistakes in the next couple of slides, okay? Finally, I'm going to divide both sides by negative 2, which gives me negative 5, okay? Now, just before we move on, okay, um, a lot of people will do this guaranteed. This is based on part B right here, okay? This is all based on part B. So I'm going to tell you what people always like screw up on, and I don't like seeing it. I don't want to give people like wrong stuff just because they couldn't do it, like just because they forgot about it. I don't want to do that. It's super annoying to deal with, okay? So I would rather not deal with this kind of stuff. Um, so let's just look at a general example. I have negative 3x plus 7 equals negative 11. As you can see here, I'm trying to get rid of plus 7. So what I'm going to do is minus 7 to both sides. As you can see, that's what I'm going to do. So negative 3x plus 7 minus 7 equals to negative 11 minus 7. Now on the right hand side, I've just circled it in purple, but I've brought it here just to explain what goes on, okay? And I'll just rewrite this again. This arrow is terrible. What actually happens here is the positive 7 gets subtracted by 7. That turns into 0. That makes the left hand side negative 3x plus 0. And then your job is to figure out, all right, what does negative 3x plus 0 equal to? That is actually just negative 3x. Now, remember, negative 3x. So the inverse operation that you're actually supposed to apply is something different compared to what a lot of people would do, okay? So what a lot of people will do is this. They will just add 3x. Now, adding 3x does nothing, okay? It doesn't do what we want to do. Remember, what we're trying to do is solve. We're trying to solve for the variable. So why does adding 3 do anything? Like, you're not really getting rid of the 3 by adding, right? So what you should do is divide. Divide by the negative number. As you can see, negative 3x just means negative 3 times x. And the inverse operation of that is dividing. So divide both sides by the negative number, and I end up with the correct answer, okay? And that is exactly what happened around here. As you can see here, negative 2, negative 2u equals 10. What I did was I divided both sides by negative 2 instead of adding something, okay? I divided. And that's what you should do always, okay? Now, let's deal with fractions, okay? Now, if you remember, yeah, whatever you see over here, it just a numerator, you get a denominator over a fraction line. Just remember, it means numerator divided by denominator. Now, every time you see a fraction, the inverse operation you are to apply is multiply. So you need to multiply every single time, okay? So let's just go through this. Now let's just go through two types of examples right here, okay? If the fraction is by itself, okay, remember, by itself on one side of the equation, you ought to multiply both sides by the denominator, okay? So let's just do that in practicality. So I write q over 4 times 4. Now, you might be wondering, how does this turn into that? Okay, turn into my final answer. I'm going to show you what happens. So if you look at my right hand side here, so I'm going to write q over 4 multiply by 4, the denominator. What actually happens is another way of writing the whole number 4 right here, another way of writing that, like this one in particular, is 4 over 1. 4 over 1 just like that. And remember, if you multiply fractions, you always just multiply across. It doesn't matter. So q times 4 is 4q. 4 times 1 is 4. And then you're left with 4q divided by 4. So you just simplify that fraction, and it ends up with being the letter q. Now, if you notice, yeah, I started off with q over 4 times 4. And I just ended it up with the letter q. So if you think about it, yeah, every time this happens, whatever you get, whatever your answer is, especially like where the fraction is, it's just basically what's in your numerator. So in my question, I had the numerator be the letter q, and I solved this multiplication. I solved this multiplication q over 4 times 4 to be the letter q. That's all it is. So I'm just going to highlight this. Okay. That's all it is. And then on the right hand side, it's just whatever you multiply by 4. Okay, that's all it is. Now, if extra terms are present, don't multiply by the denominator. Okay, because what we mean by the extra terms is that they're on the same side of the equation, but they are not a part of the fraction. So what you're going to do is remove the extra term first, and then to do that, you just apply the inverse operations like normal, okay? So if you look at my example, I have q over 4 plus 2 equals to 12. So I'm going to get rid of that plus 2 by subtracting 2. And when I subtract 2 on both sides, this is what I get. I actually end up with this q over 4 equals 10. And then I divided both sides. And then I divided multiplied both sides by 4 because that's what the denominator was. And then, as you can see, w- it gets rid of the 4 in the denominator, and I'm left with the variable q from the numerator on the left hand side, and then 10 times 4 is 40. So that's how I would do it. Okay. So these are just a couple examples here. Please have a look at what I did. I am sort of trying to speed run some of this because I'm hoping people would understand that how I get my answers to the next lines are basically me just applying the inverse operation in the blue, and I'm just taking it one step further so I can be efficient with my spacing. But if you need help at the end of the day, please let me know so I can talk to you, okay? Oh, yeah. Let me explain this one. This one I need to be very clear, okay? So in these types of questions, you have to be careful with the first digit. Um, the first digit you see here, and it's highlighted in the yellow. So in this case, I have the number 4 and I have the number 7, okay? So what I have in yellow, you need to ask yourself, what sign is there, okay? Now, I didn't have any space on the top, so on the bottom, I've sort of sectioned it off. If you don't see a negative sign, especially where yellow is, then that means that sign is a positive sign. Okay, that's an invisible positive sign. So you must treat the number as a positive number. So as you can see, what I've done in part C and D here is I was trying to get rid of this extra term of 4, but I didn't know what sign it was originally. But now that I've confirmed that it's a positive 4, I'm now going to subtract 4 on both sides. Because if you remember, that's what we're doing. We're trying to remove the extra term by applying the inverse operation to it. Now, because we didn't know what it was before, but now that we've confirmed it, it's quite easy to do. Okay, so let's just do that. Let's just subtract both sides by 4. And then as you can see, 4 minus 4 becomes 0. And then I'm left with the fraction 5x over 2 on the left hand side, and 29 minus 4 on the right hand side is 25. Then I multiply both sides by 2. So if you remember, when I multiply both sides by 2, this is what happens. Okay, times 2 times 2. Oh, times 2 times 2, just like that. Then I pretty much, the denominator disappears. I'm left over with whatever's in the numerator. And then I divide by the coefficient, okay? So yeah, pretty simple once you get the hang of it, okay? So please keep practicing these kinds of questions. Just be careful about the negative signs as well, okay? So in part D, I can see that's positive 7. So I'm going to subtract 7 on both sides. Now 5 minus 7 ends up being negative 2 on the right hand side. Then the following step was I multiplied both sides by the 3 because that was in the denominator. Just like that. Now negative 2 times 3 is negative 6. And then on the left hand side, I'm just left with negative 2x. Then I divided it by negative 2. Okay. So yeah, that's all you got to do. This is chapter 7D. What happens if there are pronumerals on both sides? Okay. So this is all you have to do. Remove one of the pronumerals completely by applying its inverse operation. Literally, that's all you have to do. Okay. So this is what I typically do. I move the variable from the right hand side to the left hand side. Now, this is just me. You do whatever you want. I don't care what you want to do. You can move it from left hand side to right hand side for all I care. As long as you understand the concept of, okay, I need to get rid of this pronumeral entirely from one side. That's all. Okay. So what I'm doing is I'm going to get rid of that plus 3x. So apply the inverse operation of minus 3x. And that's what I've done. What I end up with is, um, if I really wanted to write it out, then yeah, I should probably write it out like the full thing just to make sure people understand. I don't want people getting confused. 12 plus 5x minus 3x equals 16 plus 3x minus 3x like that equals 12 plus 2x equals 16. And then solve like normal. Okay, just like that. So that's all you got to do. Okay. And these are just some examples here that I'll sort of just like, sort of just up the pace a little bit. If you need me to explain this, please just let me know. I'll explain it to you in class, okay? Solving equations with brackets. So if just to recap, okay, I taught you how to expand brackets. The mistake I saw was you forgot to multiply the back numbers with whatever was outside here. You forgot to multiply it. You all forgot it. Oh, I wouldn't say all, I'd say a majority of you, okay? So please make sure you multiply by the back as well, okay? So you multiply the 3 with the x and the 2. So you should end up getting something like 3x minus 6 instead. So that's the correct thing, okay? Now, to solve equations with brackets, what do you reckon you're going to do? It's pretty easy. Just expand the brackets first, then apply inverse operations to solve for the variable, okay? So this is the only thing extra. This is something new. All you have to do is just expand the bracket first, okay? So do that, then solve. So if you have a look here, that's all I'm doing. I expanded the bracket first, and then I just solved by applying inverse operations. So if you have a look here, in the first one, I expanded the bracket 3p is plus 12 equals 18. Subtracted 12 on both sides, I get 6 on the right hand side, 18 minus 12. So 3p equals 6 like this. Then divide by 3 on both sides, I get p equals 2. Now, this expansion is quite difficult because I got a negative sign in the front. So you have to be careful when you multiply negative numbers, okay? So just take it easy. So in the black is just me setting up the expansion, just so I know what to write later on. And I figured it out to be negative 36q minus 60 on the left hand side. So just write it in, and that equals to negative 132 on the right hand side. Now, just remember, I'm solving for the variable. I need q isolated. So I'm getting rid of this minus 60 by adding 60. And if I add 60 to both sides, that's what I get. Oh, this is not supposed to happen. Not negative 72. It should be negative 72. Okay. So negative 132 plus 60 is negative 72. And then I'm left with negative 36q. Then just remember, you're dividing, not adding, okay? Don't make this mistake, please. Divide by negative 36, and that will give you positive 2, okay? So just just have a look at the slides. I'm pretty sure you'll all be fine, okay? Like you all have the skills. I believe in you all, okay? Um, Something else that you might do that's new is collecting like terms after you expand, okay? So if you have a look at the example, I'm expanding this 5 bracket x plus 2 here. That turns out to be 5x plus 10. And then as you can see highlighted in green are like terms that I can collect. So the 5x and the 7x. And 12x plus 7x just equals to 12x, which is highlighted right there. So you'll be along this line here, 12x plus 10 equals negative 14. Once you reach this stage, you can just like continue on like always and just solve, okay? That's all you got to do. So have a look at this here, see if it matches. If you're stuck, let me know, okay? Mm. So do 7G, given formulas, solving for them, okay? It's pretty simple once you figure out what the intentions are, but I'll just talk it over it briefly, okay? So this is when you're given a specific formula. And then they also give you values to substitute in, okay? So what is a subject anyway? Subject of equation is a variable or polynomial that appears by itself on the left hand side. So for example, you've got your area formula. This is a area of a rectangle, okay? So yeah, just remember that, okay? So yeah, A is the subject, and then the L and W are just like values that you use to sort of find what it is, okay? So make sure you substitute all known values and then solve the equation by finding what the unknown equals to, okay? So if you have a look at this example, yeah, you're just going to apply the formula for perimeter of a rectangle here. So this is the formula, P equals 2L plus 2W. And then if you have a look here, the question says find P when L equals 7 and W equals 4. So you have some values to substitute in already, and your job is just to find the missing unknown, okay? And that's what I've done in this part here. And I end up with 22 units. Now, the question here is saying find L when P equals 40 and W equals 3. So this you have to be careful here. So I know P equals 40, so I'm going to substitute P equals 40, and I'm going to substitute W equals 3. Now I'm solving for L. So over here, I am technically solve for L, aka length. And that's what I've done. And I found out to be L is 17 units, okay? That's 7G done. Yeah. So 7H, making your own equation from worded description and solving them. So there will be quite a bit of this, okay? You need to sort of get used to it, okay? Just do the questions. Stop crying, stop whinging, stop complaining. Just do the questions, okay? Like the reason why I give you this many is because I need you all to practice and get used to it. So how are we going to do it? Step 1, define variables for the unknown number. Step 2, write an equation describing the question. Step 3, solve the equation algebraically. Step 4, include units. Now, this just depends on the question. So you must have some common sense when it comes to this part here. And then step 5 is write your answer as a sentence, okay? So, um, so you have some examples here. So this is like age gap, okay? So if you have a look here, John and his elder sister are 4 years apart. So keyword, John, elder sister, 4 years apart. Now, if the sum of their age is 42, and then the question's asking overall, how old is John? Okay, so some key bits of information already. You have the word sum, meaning plus. So that means you are adding both John and his older sister's age. Um, and then you're given the fact that they're 4 years apart. Okay. It's like, for example, if I am turning 28 this year, then my older brother is currently 32 years old. And if we add those two numbers together, 28 plus 32, I end up with 60 years old in total. Okay. So we're just going to apply that to this case, okay? But you're going to do it algebraically. So how are we going to do it? Step one, just follow the steps, okay? You'll be fine. So what I've done is I have let x equals let x be John's age. Oh my god, what am I saying? Ugh. Let x be John's age. Step two, I'm writing an equation. Now, what I'm doing here is because we know x is John and then his elder sister is 4 years older. So you're going to write John's age plus 4 as his elder sister. And remember, the question here is saying the sum. So you are actually adding those two ages together, and it should result in 42 years old in total. Then step three is just solve it like normal. Okay. Now I have figured out that x equals 19 here. Now I'll just tell you what happens here. So this is a collection of like terms here, x plus x. And then what I've done is I've subtracted both sides by 4. And then I divide both sides by 2. And that's how I got x equals 19. Okay. So if you do your working out like this is perfectly fine. This is perfect. And then step four, adding units. Now, because we're talking about age, if that's the question, yep, we're talking about age. So you do x equals 19 years old. And step five, just write your answer as a sentence. John is 19 years old. So you just follow this every single time, okay? Just follow these 5 steps. Depending on the question, you'll be perfectly fine, okay? Just read the question carefully, break it down, okay? Inequalities, 7i, so the second last chapter, pretty much. So the following 4 slides technically mean the following, okay? The value on the left-hand side is blank, then the right-hand side. That's all it means, okay? So this one means left-hand side is less than right-hand side. The value of the left is lower than the right. This means that the value of the left is less than, or it could be equal to, the value of the right-hand side. No way, writing this is the value of LHS. Oh my god, what am I doing? Less than or equal to the value of right hand side, okay? That's all it means. Now, this means the value of the left hand side is greater than the value of the right hand side. What's going on? So this means the value of the left hand side is greater than or equal to the right hand side. Right here it means less than or equal to. This one just means less than. Okay. Now, inequalities with range or spread. So sometimes you'll be asked, what the value is given a spread. Okay, so you need to understand what it means and how it sort of looks like. Okay, so I have this example here. 2 is less than a, and a is less than or equal to the number 12. So this is what it technically means. Okay, a is bigger than 2, but it's not 2 itself, but it is at most 12. Okay, so you sort of need to just sort of break down the inequalities. If anything, just read it from left to right. 2 is less than a is less than or equal to 12. Therefore, a lies within this sort of range here, okay? So, something else that you need to understand is that inequalities could be reversed as well, if you did not know. Now, if you read this, 3 is less than x, okay? Uh, So this just means, uh, so all this means is 3 is less than x. But if you write it like other way around, so what we did was switch position and flipped inequality sign. This means x is greater than 3. And it technically means the same thing as our example, okay? But it's just easier to understand. So we know like the number 3 is less than x, cool. But what other values does x satisfy? Like it's quite hard to read and understand from that point of view. So if we just write it the other way around, we can write it that uh x is greater than 3, and that makes our life 10 times easier. Okay. Now, on number lines, you're gonna need to know how to draw these kinds of inequalities. Pretty simple. Only two inequalities represent open circles. So you got the greater than or less than. It's the one without the lines, okay? So without lines underneath. That's the easiest way, okay? So when you do that, the circle is not shaded in. So when you draw on a number line, you just draw something like that, okay? It should say something like that, okay? You do not shade it in. Closed circles, you see what I've highlighted, the line underneath? When you see the line, it always means closed circles. So basically, same example, 3, just draw a circle, shade it in, okay? Shade it in nicely, okay? Now, there are steps to draw a number line. All you're going to do is draw a horizontal line on the range, depending on the range of the inequality. So this is your axis right here, okay? Step 2 is draw an open or closed circle based on the inequality. The location of your circle is what your inequality number is, okay? And step 3, draw a line in the direction of your inequality. So let's just go through this right here. I've made life a bit easier because I've already done it. So yeah, I have over here x is greater than or equal to 4. So I'm going to draw a number line. I'm going to mark where the number 4 is. I've indicated whether it's an open or closed circle. And then you see the direction this arrow is pointing? It's pointing towards the right like that. Yeah? So that means I just draw an arrow that way. So towards the right. Now this one, arrow is going towards the left. So I'm going to mark where 6 is. I'm going to draw an open circle and my line's going to go towards the left. Now in the final one over here, 1 is less than x, but x is less than or equal to 5. So bigger than 1, not including 1, but less than 5, but it could include 5. So you just mark where 1 and 5 are, draw the circles depending on the inequality. So I must say, so this 1 is in correlation to that, and this 5 is in correlation to that inequality. So that's how you can tell which one's shaded and which one's not. And then you just draw a line between those two numbers, okay? All right, solving inequalities. So same steps you would normally do when you solve regular equations. Now, you treat the inequality sign as a pseudo equal sign, okay? So just pretend it's an equal sign, but it's not actually an equal sign, okay? So solving inequalities normally, if you just look here, my steps are pretty much the same like normal. And you actually might get asked to draw a graph after solving for the inequality as well. So as you can see, I found my answer to be x is less than 3. So I marked where 3 is on my number line. I drew an open circle. And then I looked at the direction my arrow is pointing. That's pointing towards the left. So I drew my line going that way. Okay. Now, this is something really important. Uh, so the inequality sign switches only when you multiply or divide by a negative number, okay? I need to highlight this really specifically. Only by a negative number, okay? So if I solve it like normal, minus 4, so 4 minus 3y minus 4 is greater than 10 minus 4. I end up with negative 3y is greater than 6. And then when I divide by negative 3, I end up with y is less than 2. Hold on, let me see now. Let me just fix this up. So as you can see here, the sign changes. So y is less than negative 2. So this means x could be any value less than negative 2. Okay, so if I draw a number line, so yeah, there we go. So we know negative 3 is less than negative 2. So yeah, it works out. Okay. So you got to be careful sometimes. Okay. Now, you might be wondering why, what's it called? Why does the inequality change signs whenever you multiply by a negative number? Pretty simple reason. So pretty simple reason. Uh, so let's just compare this inequality. 3 is greater than 2. That makes sense, yeah? Because we both know that 3 and 3 is greater than 2. So let's just mark it on the number line, yeah? Green being the number 3 and red being the number 2. Now, let's multiply the inequality by negative 2. So if I multiply the inequality by negative 2, look what happens. I'm using the same inequality, by the way. So let's just write the same inequality somewhere here. So I now have 3 times negative 2, which is negative 6. And then I have 2 times negative 2, which is negative 4. Now, now I'm keeping the same sign. So look at my sign here. My sign is exactly the same. I haven't changed it yet. But let's look at the inequality really quickly. Negative 6 is greater than negative 4. Now, that doesn't sound correct because we know in reality, negative 6 is definitely not bigger than negative 4. It's in fact smaller than negative 4. So that's the reason why we switch the inequality signs around, just to make sure that the statement is always true. Okay, so that's why we do that. So, another scenario that you may possibly get is when you do solve, okay, you might want to switch um, the whole thing, the whole solution around. So if you have a look here, I've solved it. I've solved this equation here by saying 1 is greater than x, but I've decided to write it the other way around. So what I've done is what am I doing? What I've done is I've decided to switch these, and then my sign gets switched at the same time. So the position of my 1 and the x switches completely. And but by doing that, I also have to change the sign of the inequality. Okay, so change sign of inequality, because our inequality was originally 1 is greater than x. Okay, and then when we write it the other way around, x is definitely not greater than 1 because we just established earlier that 1 is greater than x. So we need to make sure that inequality stays true. So we say x is less than 1. Okay. Now, these are just some scenarios where I've just solved like different types of equations, and then I'm just going to like draw the number line. So you can have a look at that in your own time on the sides. Okay. Take care. Ah, this is long. Oh, man.